I work for Badoo. If you're not aware, Badoo is a dating app. It's used in over 119 countries, I believe. We have over 418 million users worldwide, and multiple languages. If you were here before, you may have seen Sasha Bendin's talk about live shots. Nice of you to turn up, yeah. So yeah, we, as I say, 418 million users worldwide. So you can understand that our changes impact a huge number of people. And so in this case, QA, visual regression testing, making sure we don't break everything is quite important. And as a JavaScript developer, it's my job to break things, so it's even more important. So this is just a plan of what I will be talking about today. So predominantly, what is VRT, why to use it, when to use it specifically. A brief introduction to the tools available. It's an ongoing topic that's gone on for a long time, so there's obviously many tools available. And more to the point, I'll be trying to build a VRT solution in front of you, not live coding, because I am not good enough, but I have copied and pasted plenty of code from the internet. So, oh no! So, ignoring the inevitable failures of my presentation, I will be finishing with pros and cons, and I will be giving some real-world examples of the failures in Badoo. So, what is regression testing? I am too lazy to describe, so I copied this from the internet. Literally visual, which means something which is obviously visual to you. So if you used to look at a website, something which is the user interface. Not so much the functional side, which is if I click, does it do something? It's visual. And regression, which is just make sure you don't break anything. And revert to a previous self. Normally this would include, for example, I try to click something and the clicking doesn't work, which is kind of bad. So yeah, I tried to put this together, and as you can see, something that's the idea of visual regression testing is to make sure that you don't break something inside your application or your website, which the user will obviously see. Functional testing tends to deal with the clicky do thingy, whereas this is more, I see, it looks bad, someone's to blame. I did try and ask my Russian colleagues to help me with a Russian translation, and other than visualny regressia, the best we could do was uhudzhenia. Excuse my pronunciation, perfect Russian, yeah. Oh, thank you, yes, yes. That's how you know you've done something wrong. So, moving on from this. Why VRT? So visual regressions tend to be quite difficult to find, mostly because it's quite hard to check the entire application after a number of changes have been made. So visual regression testing will try to help this by automating this. So it'll find changes which are difficult to see. Additionally, automation is really easy, and it's also really reliable. So if you had a number of tests, you know what's going to happen. You can expect it. So if something goes wrong, it's easy to find out how, and easy for not just QA to reproduce, but also developers. Visual regression also helps to avoid change blindness. So change blindness is It's a relatively new term that's arisen in the world. I'm English. Arisen in the world. It's a phenomenon where if you pay attention to something intensely, you will not pay attention to other things changing around it. So, for example, if our developers or our QA are testing or checking a new feature, they will be very intensely concentrating on that feature. And so if something else in the application changes or breaks, it may not be obvious for them to see. So as an example of this, we have, I wanted to provide a test for you guys. So this is called a selective attention test. It is originally by Simmons and Chabris. They are psychologists and general scientists, anyway. But it's just an idea of how something so obvious can happen whilst you're trying to pay attention to something intensely. So I have a video, if it will play. Hooray! Please pay attention to the board for a couple of seconds. So, how many passes? Roughly? Well, there's 15. But did anyone notice the gorilla?
Сделали между собой люди в белых футболках.
Some people did.
А кто заметил гориллу?
The aim of this test is to show that as you're concentrating on
в том, чтобы показать вам, что когда вы концентрируетесь на одной вещи слишком сильно,
in this case, it's a gorilla,
то вы можете упустить что-то другое у вас перед носом.
To miss. So, I have another game as well, because it's easier than actually giving a presentation. I want to play Spot the Difference. So I'll give you a few seconds. These are two images, almost the same. See how many differences you can spot. I'll give you however many 5 clicks is. Your time's up. If you didn't get any, you're too slow. So roughly how many? Maybe 4, 5, 3. Okay. Well, unfortunately, you may have missed a few if you only counted 3. So it tends to be easier, actually, if you compare 2 images over the top and switch between them. So let's try and make it easier. As you can see, if I jump between the 2 images, the differences tend to be quite obvious. However, some may not have noticed the change at the bottom with, what did I press? So if you overlap the images, you'll tend to notice more obvious differences. It's also a lot easier if you just ask a computer to do it, because humans are lazy, and you can see now that actually there's quite a few more than just 3. There's quite a few. But this is a good example of differences which may not be immediately obvious to our QA or our users. So, how does VRT work generally? So actually it's pretty simple. You generate a baseline image. So a baseline image is it's what you would consider a production state. So whatever your users see or expected to see, it is your baseline. So production, master, depending on if you're a developer. So your baseline is just an image at this state. After this, it's normal for a development flow to add some changes. So maybe you want to introduce a new feature, you may want to make some changes, fix a bug, whichever. So developer does his stuff, he breaks everything, totally normal. You take another screen capture, so this is something that you will then compare to your baseline image. So normally you would hope that nothing changes, but inevitably things do break. So if there was a breakage, you would be able to tell. This kind of testing is not a replacement or even trying to do stuff that other people do for us. So most regression testing is normally done by a QA developer when they're checking a product. However, this is designed to just be another slice in the testing testing block, if you will. So this is an image I've stolen from one of my colleagues, Nikhil Verma. He also works at Badoo. I kind of told him I was going to use it, but whatever. And it's known as the cheese block model. And what this means is that changes from one side, when they're being tested, if there is a failure, the idea is each slice of the cheese will stop it from showing or catch it before it gets to production. In this case, we have unit testing done by the developers. We have the automation testing, the functional testing written by QA. And then we have the visual regression testing before human testing. And the aim here is to spot obvious failures before they reach QA, so we don't spend time, but also to alert the developer as soon as we understand that there is a problem. So what kind of cases is this good for? Functional testing obviously tests particular use cases during the application, but they don't care about platform or anything. Visual regression testing is extremely useful for testing on different devices. So instead of testing the same functionality multiple times, you can test on different devices to make sure that the interface hasn't changed. So typically you may say, oh, I'm going to change something for mobile specific very good. Specific interface. And it can happen that it will work fine for the interface. Everyone will test the interface for the mobile, and it will be fine. But then when they go to desktop, everything has gone wrong, everything's on fire, and so it breaks. Additionally, it's very good if you have a product which has multiple themes or brands. This means that if you try and update a theme for one particular place, or you make a change which could affect multiple brands, you catch it sooner across multiple brands instead of testing all of them manually. Furthermore, in development, especially with continuous integration, because changes happen very frequently, it's a good idea to cover them so that if something does go wrong in one of these changes, you can catch it before it's merged into all of the other changes. Because God knows if you have 20 changes in one branch, one development branch, trying to find out which one of these changes caused a problem is going to be chaotic. So, I would really normally say what's available, the tools available to you. However, I'm lazy, and I decided to just forward you to someone else's work. And in this case, I am pretty much copying the work of Mr. Alexander Wunschik, I want to say it correctly. He has generated this GitHub repo. It includes a number of sources of the tools available for us to use. So this includes things like browser automation. So you can see at the top the obvious Selenium. We also have the new Headless Chrome, which is what my example will be written in shortly. And a number of other devices, WebDriver, for example. These are used to run your application or run the website and just generally load it so that we can start testing against it. On top of this, we have the frameworks. So we have, as you can see here, a number of frameworks on top of these browsers, on top of this automation. This will allow us to give us some utilities which we can use with the testing. For example, being able to take screenshots, being able to run tests in a user-friendly manner, whatever that means, and generally just provide helpful utilities. Further to this, we also have online services. So as you can imagine, a lot of visual regression testing happens on the web, and an easy way to do this is by just asking someone else's service, can you check if I've had a regression on my website? It will then compare and give you a report, and it doesn't involve you having to do anything. Generally, they are proprietary, so you have to pay for them, but still useful to have if you're even lazier than me. On top of this, they also have blog posts and talks from the community. So visual regression testing has exploded recently due to the release of Headless Chrome. But generally, the community is very active, and we try to fix what we can. So as I mentioned before, instead of using such a system, or if you want to use the tools available, you can build your own. So I want to give a brief overview of what this entails. So this includes general architecture. So as I mentioned before, if you want to test your application and start visual regression testing, you need a way to run your application that we can read it. So similar with the rest of automation testing, we have a browser, or we have some way of opening the application. Generally, you'll also have the tool, which takes screenshots, and it will be able to write your tests in. So it'll be navigating to certain pages or navigating some part of the application and taking a screenshot there. And something to compare. So it's great and all that we can take screenshots and we can get images, but you do need a way to actually check them. And if you don't have that, then you don't really have visual regression testing. You just have lots of screenshots. So a brief history of how we implemented this in Badoo. When I joined the company, they had a system in place already, which was running on Phantom.js. If you're not aware, Phantom.js used to be a browser replica that you used to be able to open your site in a JavaScript context and take screenshots or manipulate the web page. However, it was discontinued with the release of Headless Chrome. On top of this, we used to have Casper and Phantom CSS. These provided us utilities to navigate throughout the application and also take screenshots. Casper was especially nice. It gave us an interface with which to write tests, which we could then say pass or failed, and then report back to the user, 50 tests passed, 150 tests failed, you're a bad developer. And on top of this, we also improved with a custom interface. So having a command line utility or just a number sometimes isn't very helpful, so we provided an interface which allowed you to compare images. And this was particularly helpful to be able to spot the differences. Often when a user had a failure, they would compare the baseline image to the check image, and they still couldn't figure out that something was broken. Figures. After this, eventually PhantomJS died because Headless Chrome was released. So this is just a Chromium browser which runs without a graphical user interface, so it just runs in the background. This actually replaced both the browser, but also the tool on top of which, with the screenshots. So Headless Chrome tends to be coupled with Puppeteer. It's a library introduced by Google. Allows you to control the browser and also take screenshots and to generally do what you would do if you was a developer, if you was to open console. So moving on from this, I wanted to give a brief example to just show how easy it can be to implement visual regression testing in your application or product. So in order to do this, I had to create a website, and I didn't want to use something that you already know, so I created my own. And as it turns out, I'm not a very good web developer. It looks like something from the 90s, and not so great. However, it's very simple, and it proves the point. So if you can see, I just have, actually, there's nothing really to show. We have 2 items at the top, not even links. I was too lazy to include a URL. But generally, there's just 2 links at the top. We have the content, which is a picture of some idiot, and we have some text. On top of this, I wanted to include another page because I really like cats. So we have a picture of a cat, obviously. So let's start. So we can try and start writing our solution for this. So in this case, I want to use Puppeteer because it's easy and I know how to use it. There are many other options, but here we're choosing this. So we start by yarn add Puppeteer, Puppeteer Core. I use yarn, you can use npm, you can use whatever you want. In terms of the Puppeteer and Puppeteer Core was originally part of Puppeteer, includes a lot of the base functions and utilities required to work with the browser, but you can implement them separately. They were split out because keeping everything in one place was too large and cumbersome. So we install Puppeteer, we assume everything goes okay. In reality, it may not. You have the internet to check what happens then, but generally it works fine. So we say Vim screenshotter. If you don't use Vim, bad luck. If you do use Vim, even worse luck. So we start by reading Puppeteer. We import Puppeteer, as be expected, and we expect to read arguments. So in this case, the arguments will tell us the file name. So just to give a brief overview, screenshotter is a utility that is aimed to take a screenshot and provide us a picture of what we expect. So the arguments here would be a URL and the name of the photo or picture that we expect to export. So in this case, we have to get arguments. You can ignore if it looks a bit strange. That's just how we read arguments in Node. Puppeteer especially uses async await functions, so they work entirely almost in promises. And the easiest way to work with those, at least nowadays, is using async await. So we have some strange syntax. Basically, it's just you can't. Well, as you can see at the end, we're just writing a function which is immediately invoked. So it will apply as soon as the file is read, or as soon as we run the script. Yeah. So actually, the main part is of our screenshotter is to open a website and just take a screenshot. So here we say, Puppeteer, please launch your browser. Please create me a tab. Generally, this is done if you're using Chrome anyway, but we have to be explicit with Headless Chrome. And we say, please go to the URL we've provided. So as I mentioned before, it awaits. So it's waiting for the browser to finish loading the page. And this is, if I remember correctly, is on document load. Once this is done, we ask, please take a screenshot. Here is an image. Make sure that we add PNG to the image name so we don't mess everything up. And then we close the browser. Pretty simple. Actually, all of this was copied and pasted from their GitHub repository, so nothing is new or unique here. After this, we say, OK, we've written our screenshotter. Let's make sure it works. It provides us this horrible picture, and we can continue with the rest of our application. So now we need to prepare a comparison utility. It's great taking screenshots. So let's say we take a screenshot of our production, our baseline. We want to take a screenshot of our check. How do we compare them? In this case, we write another. We write another small utility, and this uses resemble.js. For those that don't know, resemble.js is just a small JavaScript library which allows you to compare images and will give you some information about the difference between these two images. So we install resemble.js, and we start writing our comparer. So what's actually in the comparer? We need to read from the file system. So we have two files we need to compare. We need to compare the images, so we use the compare images utility provided by resemble.js. And then we also need our arguments, so we need to say, I expect two images, one baseline, one check. After this, we read the file, make sure we've got the files, and then we compare them, and as you can see here, we just console log the data. So just pure data, we output it to the console. And actually, that's pretty much it. That's all there is to make visual regression testing. You can check that it works. So we say, please create a screenshot of our changed file, compare them, and then you get this information from this. So as you can see, we have there's a lot of other data, which may or may not interest you, but in this case, we care more about the mismatch percentage. That is to say, if there is a change, it will tell you the percentage of the significant difference between the two files, so how much of it is different. It also helpfully provides you some bounds to tell you where the change is. If you're that interested in it, then good for you, but generally, you don't need to worry. And they also give you some other utilities, such as being able to see a diff of the picture, which I'll show you after. So this is the image. This is the check. As you can see, there's nothing. It's all fine. So let's make a difference. I helpfully just decided to change the picture so that it was round, because everything nowadays has round edges instead of being a square. So let's try again. We try and run the check. We compare it, and we can now see that there is a difference. The mismatch percentage is 3.31% of the entire screen. So we know there is a problem. Well, in this case, it's not a problem. It's to be expected. And so we can rely on this service as working. From this, it's not very helpful. Looking at text, looking at such intricate data can be time-consuming and also really, really boring. And actually, this is where the picture comes in. So you may remember we said console log, but you also may remember that in the console logged data that we had this function, get buffer. What this does, as I mentioned, it gives you the data back, the file data. Helpfully, though, it will also show you the changes in the file by highlighting them in bright purple, so you can't really miss them. And to make use of this, we just need to update our comparer to handle this data and to output it. So here, we take the file that we've inputted, so for example, check.png. We want to replace it with a not replace it, but create another file with the data from our resemble.js comparison. So we just append .diff.png to the end of the file name so that we can use this. And then we just update the file, and when you finally finish it and run it, you get this lovely image. So you can see the difference is quite obvious, it's purple. You may notice that this slight blip here, actually this turns out it's the same image as the background color, which is really, really coincidental. But still, nonetheless, you can see the change. So this is particularly helpful, and if you can imagine, if you have a complex site, seeing lots of these and showing the images like this can be quite helpful. So because this was an expected change, we can now say, let's update our baseline. This is the new production version. However, we can't forget about the kitten. And of course, with any change from a developer, something must break. And in this case, we need to make sure, or we need to check what I broke. And so we run this again. We take another comparison, and we've broken the kitten picture, to be expected. what this aims to illustrate, I know it's a very simple example, but it illustrates that with complex sites, especially large web applications or large mobile applications, even a small change can break something somewhere else without realizing, even if it looks like it's a good change. So this is just a brief example to show that our interface is composed of lots of different components. As you can see here, we have one component which is pre-selected and another component which is not. So each component has their states, their different modifiers. We also have fonts, texts, which are completely separate from our application. So at Badoo, we have lexemes derived from a server. So if something on server changes, we would also see that this changes as well. And furthermore, buttons are another example of something which can go horribly, horribly wrong. So in general, the more complex a website is, the likelihood of you introducing a bug or something which just changes the UI just slightly is very, very high. So the example that I gave is very simple, and it's a good idea to make it more usable for our developers and for our QA. So how can we do this with large-scale projects? And the answer generally is more automation. So we're automating the ability to check, and now we want to change to set this up so it works with our continuous integration tool, and something's breaking. So for us, this would be TeamCity, but if you can run this tool and have it reported every time a user makes a change, so for example, if a developer pushes a new branch or pushes a change to a branch, we can just run it. It's fantastic. And with notifying this, you can send the developer or the QA a notification, so a message or an email, and it will tell them that something is wrong, and they can check it before any manual testing is done. This will save your QA time. It will also save the developer time having to fix it later. Additionally, just having a look at files individually is a bit cumbersome and it's not very useful. So we suggest, or I suggest, introducing an interface which makes it much, much easier. In this case, this is the interface that we use at Badoo. It's quite robust. It's very, very, very minimal, but it does its job. And basically, it just says, we're going to run our tests. We have failures. We have passes. No one cares about passing tests because it means we didn't break it. People care about breaking tests because we like to blame people for breaking shit. So, stuff. And so we just give this handy interface which shows the baseline image and then the check image and the diff between them. Also, we provide a slider so that you can check between one and the other, but generally just showing this is enough. Unfortunately with this, there are also downsides. So inevitably with everything there are downsides. In this case, mutable content is particularly problematic. If, for example, you have a website which has ever-changing data, so maybe you have a date, a time, or maybe you have user images, if you compare one to the other, you can expect that they will fail because the chances of two users having exactly the same image are quite slim. So in order to counteract this, you need to either put your own data into the website or modify the site so that you remove this particular stuff. In our case, we remove user images and use placeholders instead. We do this through Puppeteer, but you can modify the data before it gets to your application, for example. And so that will resolve it. Additionally, it requires a lot of maintenance. With a lot of large projects, you tend to have a lot of features coming in and out, and often these are split by tests. And if you're testing something on a user, you've got to be sure that your VRT is covering it. And from this, it just requires time. So whoever is maintaining it just has to monitor it and make sure that it's up to date. Often you'll find a test has been finished or released, and it will break the VRT test. But you won't notice this until long after. Additionally, it's not pixel perfect. Different machines, different people's processors, different graphics cards will change how the website looks. And for things such as border radius, this can sometimes be a problem. Sometimes if you run the test, you'll find that there are slight pixel differences in what is shown. And so for this, you have tolerances. So if you remember before, we had the mix, the match percentage, how much of the screenshot was changed. You can set a tolerance to say only alert the user if their percentage of this change is above a certain amount, so 0.1%, for example. But it's something to take into account, especially anti-aliasing. Additionally, these services tend to be quite centralized. It's very difficult for you to run the test locally and then compare. Well, it's not difficult. It's time-consuming to compare against a remote resource. Let's say, for example, I take a lot of screenshots. I upload them to one place. If I want to run it locally and then compare, I either have to download all of those screenshots or I have to upload my screenshots so they can be compared on that service. So it's still quite cumbersome. You should either run it locally or on a remote server. But there are upsides, of course. I mean, any kind of testing has its upsides. In this case, it's another level of safety. So not only do you have the unit test, the functional tests, and QA testing, but now you have another check, which will check on a much broader scale. So for example, different brands, different devices. It can check all of them so that you don't have to. Additionally, it's, like any testing, it's documented and reproducible. So all of your tests, if one of them fails, you have step-by-step lines to tell you how to check it. And as mentioned, there's a wide range of tests. So you can test against lots of different things. So it's particularly useful. In this case, I wanted to provide some real-life failures. So these are failures from Badoo, our application. Not quite introduced by me, but possibly some of them were made by me. And some of them are not so obvious. So this is an example of our interface for older devices. So generally, we have kind of the typical swiping action for our users. But on older devices, we don't have this available. So when you open a profile, we have this close button so that we can say, you can close the profile. Inadvertently, one developer, definitely not me, maybe me, slightly removed it. And as you can imagine, as a user, if you go to open a profile and then you can't navigate away from the profile, not the best user experience. So this actually caught this quite nicely. And because it's on an old device, specifically designed for old devices, we may not have caught it during manual QA, because we tend to test on new devices. This is another one. Actually, this one is very important, really. We changed something, and we changed the color of the online notification. Seems like something small. However, for our users, they tend to like messaging people that are online. And if you can't show that someone is online, you don't send so many messages. So in this case, we accidentally removed this. Actually, we didn't catch it in VRT. It was sent to production. And we started noticing that all of our users were sending less messages. So something so small that you don't notice it can have a really big impact. Especially here, we had functional tests which checked for the existence of this icon. And the icon still exists. It's still there. It's just hidden. It doesn't have any CSS applied to it. So it's just an empty, it just looks like empty space. So the functional test passed, VRT failed, caught us again. And this is just another small kind of failure. It just shows you alignment differences. If you remove something or just change some simple CSS, you can see that instead of it being centered as before, it just moves to the side. So actually, that's it from me. I don't have much else to say. Cheers. I will be shortly updating this to upload my code examples, but yeah. So is there any questions? Maybe? No? We have one question. Oh, that's bright.
Thank you very much. My name is Svetlana. I'm
Nice to meet
from
you.
2JS. I'm a back-end QA, so I don't have much experience with the user interface. But how do you tell expected changes from bugs? You have obvious difference, and okay, it's expected change, it's expected change, it's an expected change, and you may as well lose a real bug if you see it as well as expected changes.
It's very possible, yeah. Generally, it requires just communication between the developer and QA. So if we treat the visual regression tests as a complete source of truth, any kind of failures should be discussed or spoken with the developer to make sure that it's expected.
Thank you.
So, you're welcome. We have another.
Hi, my name is Mirjana.
Nice to meet you.
And nice to meet you. Great talk. Why did you choose resemble? Was it because it is a command line or the API, or what was the reason that you choose resemble?
Honestly, it's the first thing that came up when I Googled. So actually, it's as simple as it was the first thing that came up, and it had the simplest code example. So the examples that I gave are largely copied and pasted from the websites of the corresponding tools. So
Thank you.
yeah. Any more? Oh, we have one more.
Vadim,
That's me.
who provide you images to compare with? Design team makes screenshots, or you take screenshots from released version and compare it with from previous releases and compare with new releases?
As you can tell, most designs that come from the design team don't tend to actually look like the final product at all. We take the screenshots ourselves. So we take a look at the release version and take the screenshot from there. If you're releasing daily, that means you update your baseline images every day to match, to make sure that you have the most recent version. Yeah.
Hi, Karl. My name is Anton.
Nice to meet you.
Thank you for explaining about that. Resemble.js was the first framework which you found, and why are you based on JavaScript? Why not your Python or other languages? And maybe you can suggest something for Python.
I'm not sure about Python. You have Imagic for your for Python, so you can use that for image comparison. I believe. I think they have something built in. But for me, JavaScript is just because I'm a front-end developer. It's the language I use most often. There are plenty of other tools. There are tools for Selenium. There are tools that run on Ruby, for example. So actually, there is no reason why you should choose one or the other. If you can, as hopefully shown, you can write a tool very quickly in a very short amount of time. So, yeah. Cool. Oh, we got another one. Hooray! Someone cares. Oh, we've got two. More people care. That's several. Hi. Nice to meet you. Cool.
Quite often, some tests are failing. So how often do they have 100% success?
Very rarely. Generally, there is always a small percentage of tests which fail just because unexpected things happen. This can include notifications appearing, as shown in one, well, not shown, but generally you don't expect 100% of tests to pass all the time, similar with any kind of automation tests. But generally, it's up for the QA to be able to say, well, this is obviously okay. Nothing's unexpected, so it's not such a problem. Developers, on the other hand, aren't such a fan of receiving notifications every time their tests fail, because if they fail 100% of the time, they tend to ignore them quite often. So, yeah.
Hi, my name is Eugene.
Nice to meet you.
Thank you for the presentation.
Thank you.
The question is, how long does the test run goes? I mean, you have a website, you have a couple of the apps for different operation systems. How long does it take to check everything?
So the system is mostly automated, so we don't really notice it. For applications, the screenshots process, our native applications don't currently have it. They're in the process of implementing it due to the difficulty in collecting their screenshots and running it locally. However, for web, they tend to run in just 3 minutes or something for about 300 tests or 200 tests. So it's quite quick.
So you run it only on the web application?
Yes,
Uh-huh.
currently.
Thank you.